Close your eyes and picture the solar system. If you are like most people, you likely see a bright, burning star in the center, surrounded by a series of neat, concentric rings. It is a flat, orderly disk where Mercury, Earth, and Jupiter race around a predictable track, ending at the frozen, lonely outpost of Pluto. We are taught this map in elementary school. It creates a sense of a compact family unit of planets, huddled together against the cold. But this image is a lie. It is a fundamental inaccuracy that has distorted our collective understanding of where we actually live. If you were to draw a true map of our home to scale, placing the Sun in the center and Pluto at the very edge of your paper, you would be missing almost 99% of the actual picture. The planets, Mercury, Earth, Jupiter, all the way to Neptune, are not the main features of our home. They are merely the crowded, tiny center. The true boundary of our star's domain sits thousands of times further out, forming a structure so massive, so encompassing, and so terrifyingly vast that it technically defines the outer gravitational territory of our Sun. It is called the Oort Cloud, and while it is often described as a cloud, it is more accurate to think of it as a shell, a spherical icy container that effectively locks us inside our own system. To understand what this structure actually looks like, you have to dismantle the shape of the solar system as you know it. When we look at the planets, we see a flat disk. Mercury, Venus, Earth, and Mars all orbit the Sun on roughly the same flat plane, known as the ecliptic. It looks like a dinner plate spinning in the void, but the Oort cloud does not follow this rule. It is not a ring, nor is it a belt. It is a sphere. It surrounds the Sun from every single direction above the North Pole, below the South Pole, and to every side. We are essentially living inside a massive hollow bubble of ice. The scale of this bubble is difficult for the human mind to process because the numbers are so large that they stop meaning anything to us. Astronomers measure these distances in astronomical units. One astronomical unit is the distance from the Earth to the Sun, which is roughly 93 million miles. For context, Neptune, the furthest known major planet, sits about 30 astronomical units from the Sun. That is the edge of the planetary neighborhood. The Oort cloud is in a completely different category of distance. The inner edge of the structure does not even begin until you are about 2,000 to 5,000 astronomical units away from the Sun. It then extends outward to somewhere between 50,000 and 100,000 astronomical units based on current estimates. That is potentially nearly halfway to Proxima Centauri, the next closest star to us. It helps to visualize this with a physical model to truly grasp the absurdity of this scale. If we scaled everything down so that the Earth was exactly 1 inch away from the Sun, then Pluto would be about 40 inches away. You could fit the entire planetary system, everything we have ever explored, on a large dining room table. On this same scale, the Oort cloud would not even start until you walked several hundred feet away from that table, perhaps down the block and around the corner. The outer edge of the cloud would be about 1.5 miles away. The planets are just a few specks of dust in the center of a sphere that is multiple miles wide. This massive structure is actually divided into 2 distinct regions, reflecting a complex architecture. The part closer to us is called the Hills Cloud, or the inner Oort cloud. This section is shaped more like a donut, or a thick disk, and it contains roughly 5 times as much mass as the outer section. It is much denser here, a transition zone between the orderly planets and the chaos of the outer rim. As you move further out, you transition into the outer Oort cloud, which is the true spherical shell that envelops the whole system. The objects out there are not rocks like the asteroids we find between Mars and Jupiter. They are volatile ice. You have frozen water, methane, ammonia, and carbon monoxide. These are the pristine leftovers from the very beginning of our solar system, 4.5 billion years ago. They have been sitting in the absolute cold of deep space, hovering just a few degrees above absolute zero, almost entirely undisturbed since the birth of the Sun. People often visualize the Oort cloud as a dense field of ice rocks like asteroid fields in sci-fi movies. In reality, it's much emptier and more haunting. While it contains trillions of icy objects, the space between them is vast tens of millions of miles apart. Standing on an icy rock, you'd see nothing but stars, with the Sun appearing as just a bright star, like Sirius or Canopus. It's a lonely, dark, and empty place. Many assume the Oort cloud has always been a static shell of ice at the edge of the solar system. In truth, it's much more chaotic. These icy bodies were once much closer to the Sun, forming near the gas giants. The early solar system's shifting orbits of Jupiter and Saturn, in a violent gravitational dance called the Nice model, ejected countless icy planetesimals to the outer reaches. Some of this debris was thrown so hard that it left the solar system entirely and drifted off into interstellar space, becoming rogue comets wandering between the stars. But a significant portion of it did not quite reach escape velocity. It traveled out to the very edge of the sun's gravitational reach and stalled there. Over billions of years, the gravity of passing stars nudged these objects into the spherical shape we see today. The Oort Cloud is essentially a cosmic junkyard of construction materials that the giant planets threw away 4 billion years ago. It is a frozen snapshot of our violent history, preserved in the deep freeze of the outer rim. This immense distance creates a unique physical state for the objects residing there. They exist on the absolute razor edge of the sun's control. When you are on Earth, the sun's gravity is the dominant force in your life. It keeps the planet in a tight and predictable orbit. But out in the Oort Cloud, the grip of the sun is incredibly weak. It is so weak that the sun is no longer the only player on the field. This is the region where the solar system begins to interact with the galaxy itself. Astronomers call this the Galactic Tide. Just as the moon raises tides in the oceans of Earth, the mass of the Milky Way galaxy exerts a tidal force on the Oort Cloud. The dense disk of our galaxy and the core of the Milky Way pull on these outer icy bodies. This force is constantly fighting against the weak gravity of the sun. It stretches the cloud and distorts it. It is this galactic tide that keeps the Oort Cloud spherical. It prevents the objects from falling back into a flat disk like the planets. This balance is delicate because the sun's hold is so fragile. The Oort Cloud is susceptible to outside interference. It is a permeable membrane rather than a solid wall. Other stars in our galaxy are constantly moving, drifting through the spiral arms, and occasionally they pass close to our territory. When a star passes within a few light years of us, its gravity disrupts the cloud. It shakes the cage. We know for a fact that this happens. We have identified a star named Gliese 710. It is a red dwarf currently about 60 light-years away from us. Astronomers have calculated its trajectory and found that in about 1 million years, it will pass directly through the Oort Cloud. It will come within approximately 13,000 astronomical units of the Sun. This is not a near miss. It is a direct hit on the outer shell of our system. When it passes through, it will scatter millions of comets. Many will be thrown out into the void, lost forever. But many will be knocked inward toward the inner solar system. This creates a comet shower that can last for millions of years, bombarding the inner planets with ancient ice and rock. The Oort Cloud is not just a distant border. It is a dynamic and active environment that links the fate of Earth to the movement of the stars around us. There is, however, an uncomfortable fact about everything we have just discussed regarding this cloud. We have never actually seen it. Despite all our advanced technology, despite our space telescopes like Hubble and James Webb, we have never managed to take a photograph of a confirmed object inside the Oort Cloud. We have never tracked a specific rock orbiting out there in that distant shell. This brings up an obvious question. If we cannot see it, then how can we possibly know it is there? Is it just a theoretical ghost? The Oort Cloud objects don't produce their own light, only reflecting sunlight, which makes them incredibly dark. At 50,000 astronomical units, the sun appears as just a bright star, and the light hitting these icy objects is minimal. They have albedos similar to charcoal, making them nearly impossible to spot. Trying to see a lump of ice at that distance is like spotting coal against a black background from 1,000 miles away. Optical telescopes can't resolve them, and even infrared telescopes struggle. These objects are not only dark, but also extremely cold, just above absolute zero, emitting almost no infrared radiation. Their thermal signature blends with the background temperature of deep space, making detection difficult. So, the challenge is not just lighting, but a combination of contrast, temperature, and scale. The Oort Cloud's existence isn't based on direct observation, but on mathematical necessity. In 1950, Jan Oort noticed that comets falling into our inner solar system could be divided into two categories: short-period comets, like Halley's Comet, which orbit within 200 years and originate from the Kuiper Belt, a known region beyond Neptune. But then there are the long-period comets. These are the anomalies. They have orbits that take thousands or even millions of years to complete. The comet Hale-Bopp, for instance, will not return for another 2,000 years. The comet West takes about 250,000 years. These objects travel such immense distances that they must be coming from a region far beyond the Kuiper Belt. Jan Oort looked at the trajectory of these long-period comets and found the smoking gun. They do not follow the rules of the planetary disk. They do not just come from the left or the right. They drop down from above the North Pole of the Sun. They shoot up from below the South Pole. They come from every distinct angle and inclination imaginable. The key to understanding the Oort cloud lies in the randomness of comet trajectories. If these comets originated from a flat ring like the asteroid belt, they would all follow the same plane. But comets arrive from every direction, suggesting their source must surround us uniformly in a sphere. There's also the issue of supply comets lose mass each time they pass near the Sun, eventually disintegrating or running out of ice. Given the solar system's age, all comets should have burned out by now. The fact that we still see fresh, long-period comets indicates a massive, distant reservoir. This reservoir, the Oort cloud, contains billions of comets waiting to be nudged inward by passing stars, replenishing those that are destroyed. This brings us to the most famous object in the history of space exploration, Voyager 1. There is a persistent misconception about where this spacecraft actually is. In 2012, the world celebrated a historic moment. The headlines declared that Voyager 1 had finally left the solar system. It was the first human object to enter interstellar space. While that is technically true based on one specific definition, it creates a false impression of how much progress we have actually made. To understand where Voyager is, we have to distinguish between two different boundaries. The first boundary is magnetic. The Sun blows a constant stream of charged particles outward called the solar wind. This wind creates a bubble around the planets that pushes against the radiation of the rest of the galaxy. This bubble is called the heliosphere. The heliosphere is the entire region of space where the solar wind and the Sun's magnetic field dominate over the interstellar medium. The heliopause, by contrast, is not the heliosphere itself, but its outer boundary, the thin, invisible surface where the outward pressure of the solar wind is finely balanced by the incoming pressure of interstellar space. Crossing the heliopause means leaving the Sun's magnetic influence, not its gravitational one. In 2012, Voyager 1 punched through the edge of this magnetic bubble. It crossed the heliopause. It detected a sudden drop in solar particles and a spike in cosmic rays. That was the moment it entered interstellar space. But interstellar space is not the same thing as leaving the solar system. The solar system is defined by gravity. It ends where the Sun can no longer hold on to objects. By that definition, Voyager 1 has barely left the front porch. The spacecraft is currently about 160 astronomical units from Earth. It is traveling at a speed of about 38,000 miles per hour. That is incredibly fast by human standards. It covers 10 miles every single second. But even at that blistering speed, the scale of the Oort cloud renders it motionless. Voyager 1 is currently in the empty gap between the heliopause and the inner edge of the Oort cloud. It will not reach the very beginning of the Oort cloud for another 300 years. By the time it actually arrives there, the year will be roughly the early 24th century. The tragedy of this journey is that we will not be there to see it. Voyager runs on a nuclear battery called a radioisotope thermoelectric generator. It converts the heat of decaying plutonium into electricity. That power source is fading. NASA engineers expect to start shutting down the final instruments around 2030. Sometime shortly after that, the probe will fall completely silent. This means that Voyager 1 will be a dead piece of metal long before it encounters the Oort cloud. It will drift through the darkness, taking nearly 30,000 years for this silent spacecraft to pass through the shell and finally emerge on the other side. Only then will it truly have left the solar system. This highlights the immense prison of distance we live in. We have built a machine that can travel for decades at tens of thousands of miles per hour. And yet, it will take the span of recorded human history 5 times over just to cross the threshold of our own backyard. When we describe the Oort cloud as a trap or a shell, it is easy to misinterpret the nature of the barrier. It is not a physical wall. If you were piloting a starship toward the edge of the solar system, you would not crash into a dense field of ice and rock. The danger of the Oort cloud is not what is there. The danger is what is not there. The barrier is the emptiness itself. In science fiction, spacecraft use island hopping to mine water from asteroids or moons, converting it into hydrogen fuel to travel vast distances without carrying too much propellant. This works because the islands are relatively close, allowing hops from Earth to Mars, then to the asteroids, and on to Jupiter's moons. However, once you reach Neptune's orbit, the islands vanish. The Oort cloud may contain trillions of objects, but they're spread across a vast volume, making the density nearly zero. The average distance between two objects is about the same as the distance from Earth to Saturn. This means you cannot island hop. You cannot stop to refuel. You are entering a desert that is 100,000 astronomical units wide. This creates a brutal engineering problem known as the rocket equation. Because there are no pit stops in the Oort cloud, you must carry every ounce of fuel you need for the entire journey from the moment you leave Earth. But adding fuel adds mass. Adding mass means you need even more fuel to move that mass. This exponential curve makes it nearly impossible to build a chemical rocket capable of crossing the cloud in a reasonable time frame. With current propulsion technology, crossing the Oort cloud is impossible for human civilization. A journey that would take 30,000 years is not a journey at all. It's a geological era. The civilization that launched the ship would likely be extinct long before it reached the other side. The crew would live and die across generations in the void between the stars. This vast, empty expanse serves as a natural quarantine for the solar system, keeping humanity isolated. The Oort cloud marks our physical boundaries, effectively limiting our reach beyond our own system. It is both a protective barrier and a reminder of our limitations in space travel. The Oort cloud defines our existence. It's the silent moat around the solar system, marking the end of where we can survive and the beginning of the interstellar void. Instead of a crowded family of planets, the solar system is a lonely island in a vast, dark ocean. The Oort cloud is the shoreline of this island, the boundary between our safe haven and the unknown. In one sense, the Oort cloud is a cradle, preserving the sun's history in deep freeze, waiting for us to explore. In another, it's a cage, its immense scale imposing limits on our biology and technology. It serves as a stark reminder that, despite our dreams of galactic colonization, we are still grounded. We are residents of the solar system, citizens of the galaxy second. We will likely remain here for thousands of years, but we've already sent Voyager 1 ahead to scout the way. Long after Earth's civilizations fade, Voyager 1 will drift past the trillions of comets in the Oort cloud, a silent testament to our curiosity, and a permanent monument to the massive shell that keeps us from the stars. The Oort cloud marks the beginning of the end of our neighborhood, the dark horizon where our home fades away.